This is the first of SME's webinars. We're going to be doing these through the summer. We're excited to get started and we're glad you've all joined us. We have Hayder, Al-Hilal and Shayne Giordano with us today, and they're going to talk about floor covering failures. A few things before we get started. We're a small group, so we're going to go ahead and manage questions and things using live chat. So if you will stop a couple of times throughout the presentation for questions, go ahead and feel free to unmute yourself and interject and ask your question as you know at that time. The first few slides of their presentation is an interactive sort of feature as well. So again, same thing, as we ask questions, please just unmute your mic and give your response, and we'll just keep going that way. One last reminder, CEU credits, if you're interested in those, we'll put up my email at the end and just send an email and we'll make sure that you get your certificates for CEUs. With that, I'm going to go ahead and hand over to Hayder and Shayne, and we'll talk to you all soon.
All right, thank you, Kristen. As she mentioned, thank you everyone for joining us this afternoon. Topic today is lessons learned floor covering failures. We're going to start with a couple of quick introductions, and then we'll get into the presentation as a whole. So, Hayder, if you want to introduce yourself.
Thank you, Shayne. So my name is Hayder Al-Hilal. I've been with SME for 15 years now. Graduated from Lawrence Tech. Have my undergraduate and my master's degree in 2008 in construction engineering management. I'm still going back to obtain my master's degree in structural engineering. At SME, I focus on concrete masonry and temper and NDT, non-destructive testing, bridge inspection and restoration design, reinforced concrete service life, floor system failure assessment, which we're going to talk about today, reinforced concrete, steel, masonry, and timber structure assessment and restoration design. Shayne.
Okay, so my name is Shayne Giordano, licensed professional engineer in the state of Michigan. I got my undergraduate from Western Michigan University with a focus in structural engineering. I've been at SME for 7 years now. I focus on a lot of the same things that Hayder just mentioned: non-destructive testing and evaluation of building materials, condition assessments, structural analysis and design, obviously floor system failure assessment, bridge inspection, and reinforced concrete tunnel assessments. Today, we're going to be talking about floor system distress. Some of the references that we're going to be alluding to include the American Concrete Institute, ACI, Portland Cement Association, or PCA, the International Concrete Repair Institute, ICRI, and the National Ready Mix Concrete Association. I'm not going to go through and read each one of these references. It'll be available for you guys to look at after the presentation. So today's agenda, we're going to start with some fun facts in air quotes here, and we're going to talk about some floor system distress, different types. We're going to look for some feedback from you guys on that one, and there may or may not be a quiz as well. We're going to talk about how to properly assess slab moisture conditions. We're going to focus on the calcium chloride and relative humidity test methods, and we'll touch on some other ones, which include the moisture meter, some pH testing, and absorption rate. We're going to get into case studies. Hayder's going to elaborate on some performance problems that are specifically attributed to moisture-related effects, specifically osmosis, ASR, near-surface ASR, chemical contamination, and then ultimately what we want to get out of this is how to properly assess failed floor coverings. So starting with some fun facts, we're calling this section Give Me the Numbers. So each year in North America, commercial property owners spend nearly $2.4 billion just on restoring structures and floor coverings that are directly attributed to moisture-related flooring failures. So that's $2.4 billion for that. And then to build on that, an additional $1.2 billion is spent on topical treatments alone, just aimed to address those slab moisture conditions prior to the floor system being installed. So this is the part where we're going to unmute everyone and ask for your guys' opinions. The first question in the pop quiz: what are 5 reasons why moisture-related flooring issues have become problematic over the last 30 to 40 years?
Changed glue types.
That is one of them.
Now, what is specifically changed on the glue type?
Yeah.
Hey, that's what you guys get paid for.
I guess we'll give it to you.
So from a solvent base to water base.
To water-based, yep, you got it.
Yep. Is there anything else? There's maybe something that happened in the early 1990s that had to do with a particular material.
Maybe more in the 80s to
80s, yeah.
Yeah, 80s, 90s. What changed in the the material?
It rhymes with mesmestus.
Might
Is
be
it cheating if I answer, guys?
I mean, if you can't get it after that last hint, I don't know if we
Asbestos.
can help you much more.
How about asbestos?
There we go. So I can see that's one of them.
Okay, there's 3 more.
And I think this one was already touched on.
What happened to the placement of the concrete, nowadays compared to 30, 40 years ago?
Things may be getting pushed to get done a lot faster.
Okay.
Man, you guys are definitely gonna have to stick around here, listen to us talk a little more. So we got a fast track construction schedule.
So no waiting really to let the concrete dry before you install your concrete flooring.
Right. Then so maybe what happens when you have to pump concrete up several stories? Contractors like to add something to the mix. Maybe help them from a workability, flowability standpoint through the pump.
I guess.
Maybe the use of water. And then there's one that's kind of near and dear to our heart. We call it the spray and pray application. And we'll get into that a little bit later. Next question. Adding an alkali-silica admixture will reduce concrete permeability, thus limiting the effect of external moisture infiltration through a concrete slab. And is that true or false? 50-50 shot on this one.
I'll guess false.
Got it.
Yeah, that's what we call also the spray and pray application too.
Yep. Yeah, it's part of that spray and pray category. So this seems to be a common one. The depth of groundwater table directly affects moisture conditions within a concrete slab. This is assuming that there's no vapor retarder installed between the bottom of the slab and supporting subgrade. Is that true or false?
False.
2 for 2.
Wow, this is the first time someone.
I know.
answered this.
We usually get a true on that one. So concrete in practice 28, regardless of the water table depth, water and vapor form will rise and saturate the soil below the concrete slab. So regardless of where the building is located, the relative humidity of the subgrade below the slab on ground will measure nearly 100%. Again, this is assuming that there's no vapor retarder installed between the bottom of the slab and supporting subgrade. So how long does it take for a 6-inch thick concrete slab to dry prior to receiving the flooring system?
7 days, 28 days, or 6 months.
6 months.
Wow. Okay, rule of thumb, 1 month per inch of slab thickness as far as drying goes.
Wow.
A little extra credit here. So when does the drying clock start?
Don't know.
So the drying clock starts when the building is enclosed and climate controlled. So one thing that might affect this is the building could be enclosed and all the HVAC is turned on to what the service conditions are supposed to be, but then there's a leak in the plumbing and the concrete slab may get wet because of that. you do have to start the drying clock over again.
Or roof is not.
Or roof leak.
Yep.
Yep. So we're almost through these. The pH in newly placed concrete is roughly 12.5. So given industry standards, the highest pH level that most adhesives can tolerate is 10. So how come this doesn't really cause a significant issue when it comes to floor covering installation? There's a certain kind of natural process that occurs when it comes to concrete being exposed to the environment that may cause the pH level to lower.
That process is called carbonation.
Carbonation.
You
I
don't
was
have to
just
pay
gonna
for
say
it.
that.
Happen by itself.
That's right. You don't have to pay for it.
Huh.
So different types of flooring system distress. As I'm sure a lot of you guys know, slab moisture can affect adhesion of flooring materials that are non-breathable, including vinyl tile, wood, resilient sheet flooring, carpet. And the photos here at the bottom of the screen, you can see blistering that's illustrated by the red arrows. And obviously, you can see it in the loose laid floor covering there in the locker room. When it comes to hardwood flooring, this is in a gym. The most common sort of distress is cupping and heaving. And you got to kind of get the right light to shine on the floor to see the cupping. And you can see at one of the penetrations there in the floor, it's where they put a post in there for a volleyball net for the multi-use part of the gymnasium. You can see the level and how far there's a gap between where that cap is and the level. And more commonly, debonding. That's a vinyl tile on the left there, and an epoxy floor covering on the right. That's just peeling right off. Peaking at tile seams has occurred. Before we get on to how we assess slab moisture conditions, we want to know if anyone in the audience there has experienced something other than what we've touched on, something new.
I have not.
Okay, we have blistering, cupping, debonding, peaking. We think we've covered them all, but I guess we're not getting much feedback, so I guess we're okay on that regard. And if you are a little hesitant to speak up, you can always type anything in the chat there, and we can address that too. Kristen will let us know. So as far as properly assessing slab moisture conditions, you have surface tests, which include the calcium chloride method, pH testing, and absorption. And when it comes to slab moisture equilibrium, really the only test out there is relative humidity. And Hayder is going to elaborate on chemical and petrographic analysis. For the calcium chloride method, again, it's a surface test, and it measures the moisture vapor emission rate within the upper 1/2 inch to 3/4 inch of the concrete slab. And depending on what kind of slab conditions you have, it's likely going to require some sort of surface preparation. So if you already had a floor covering on there, you're going to need to remove the floor covering itself, plus all the adhesive, any sort of curing agents that were present need to be removed. If you're clumsy like me, you got to be aware not to spill any of the calcium chloride tablets. They're really small and there's a couple hundred in there. So as far as the slab moisture equilibrium, before you put the floor covering on, you can see the calcium chloride test method on the left there, upper top 1/2 inch of the slab. And then after the floor covering, you have the option to install an RH probe. So moving on to relative humidity probes, the overview, no surface preparation required for this. It's not a surface test. And you do need a couple of bits of information before you're able to conduct the test. You're going to need to know the slab thickness, which can either be done by coring or doing some sort of GPR or referencing some original design documents. You'll also need to know the slab drying conditions. So is it a slab on ground with a vapor retarder? Is it a slab on metal deck? And that's going to dictate the depth of the probe, is the drying condition. So if you have two-sided drying, so like a supported slab, you're going to embed the probe 20% of the slab thickness. So that's two-sided drying. However, 40% of the slab thickness is going to be where you're going to install the depth of the probe for one-sided drying. So one-sided drying would be considered a slab on ground with a vapor retarder, really because moisture can only transmit through the slab surface, the exposed slab surface. So it's only drying from one side. It's probably a good idea to determine where your resteel is and any conduit, especially at any test location. And to give you a little bit of an example here, as far as the one-sided drying profile for a slab on ground, how the depth of the probe is determined or was determined for the ASTM procedure is the green line illustrated on this graph here is the initial relative humidity. So that's when it's first placed. And you'll have a drying profile that was established through extensive testing. That's the gray, kind of the wavy line, if you will. And once you put a floor covering on the floor, you have the covered equilibrium drying profile, the relative humidity profile, excuse me. So where the drying profile intersects with the covered equilibrium relative humidity profile, you will draw the dashed line here corresponds to a slab depth to thickness ratio, and it's 0.4. So that's where you get the 40% of the slab depth for where the probe needs to be installed to.
And Shayne, this is why the calcium chloride too doesn't really provide an accurate moisture reading, because you're only measuring the top. And as you can see, you know, the top could be drying because you got your relative humidity of the inside, and you're not really going to see what that equilibrium moisture after you do the covering. And that's what we are seeing now. A lot of flooring manufacturers are specifying RH instead of calcium chloride because you can't really rely on the surface test.
Right. So if this doesn't make sense to anyone, or if they have any questions, feel free to chime in here, because this is an important concept. You're talking about the slab drying profile versus the covered equilibrium relative humidity profile. So this is a measure of moisture conditions within the concrete slab, not necessarily, it's not at the surface like the calcium chloride test is. Okay, move on here. Some other surface tests I mentioned, pH testing. This requires an exposed concrete surface, and there's been some discussions that we've been a part of and heard about where people try to figure out, okay, should we conduct this test right before we put the floor covering in, or should we do it, you know, before they put the curing compounds down? I mean, when do you really want to do this test? And I would kind of lean a little bit more towards doing it right before the floor covering is laid, just because that's the condition of the surface that's going to be interacting with the floor covering. But what it involves is taking deionized water and placing a drop on the concrete surface, and then waiting a certain period of time, and then you're going to dip a pH paper in the water droplet, and you're going to take a reading. Now that reading is strictly on the color of the pH paper, so there is a little bit of an human interpretation to that. Someone might say, oh yeah, that's kind of like a reddish orange, and someone could say, no, it's a little more towards yellow. So there's a little bit of an interpretation, I don't want to say bias, but the results could be a little bit open-ended, if you will. Absorption rate, this also involves an exposed concrete surface. And this is more useful when it comes to determining the adhesive application rate. So you take a water drop and you basically time how long it takes for that water droplet to be absorbed by the concrete surface. So it's within a minute, plus or minus 5 seconds. And you can use that for your absorption or your adhesive application. So what lies beneath? And we thought the iceberg analogy might be a good way to express this. We talked about the calcium chloride test, the absorption test, pH. The moisture meter is an electronic handheld moisture meter that gives you kind of a qualitative test result of what kind of moisture is being emitted from the slab. There's also the mat test, which we didn't talk about. You tape a 18 by 18 sheet of visqueen over the concrete surface. You wait a certain period of time, and you come back and take a look to see if there's any moisture droplets that have accumulated on the underside of the visqueen. And again, that's a little bit more quantitative, more visual. And then of course there's visual observations. Those are always important. What kind of distress do you have? Do you have the blistering? Do you have the debonding, peaking? It's all important, but there's a lot more to it. And that's where the iceberg comes into play, because icebergs are usually a lot larger below the water surface. So that's where we get into the RH test. And like I said, Hayder's going to talk about the petrography and chemical analysis. And ICRI does provide a concrete slab moisture certification course, and it covers all of the ASTMs that we listed on our reference slide. It's a great course. I took it, let's see, not this past summer, but the one before that. It's very comprehensive, and you get to do all the test methods that are involved in assessing slab moisture conditions. So encourage everyone to sign up and go through that. Hyder's going to take over here. He's going to talk about flooring and moisture and get it a little bit deeper into the bottom of that iceberg, if you will.
All right, thank you, Shayne. So as Shayne went over the concrete slab moisture and how to assess the concrete slab, so now you got the test result for whether the vapor emission from the calcium chloride or the relative humidity. You compare them to those threshold value out there for flooring that requires the maximum value before you apply your floor covering. So now what happened if you over these threshold value? If you reference the industry solution per the standard, they would tell you to use a moisture mitigation membrane under the flooring. That's typically used in case you don't have a vapor retarder under the slab, and you want to control that moisture emission. So you put a moisture mitigation, which is a liquid membrane installed at the top of the slab. So that's an option. Another option is, maybe use less moisture sensitive flooring or adhesive. Some adhesive could tolerate 95, 97%, or we've been seeing a lot of new construction using moisture mitigation admixture product, the silicate product. That's what we called spray and pray application at the beginning of our presentation. And I think the problem is right here. As an industry, for the floor covering, we really discuss all these different options, but we don't really look at that iceberg, at what lies beneath, what's going on. And we'll go over, case studies that contractor used these mitigation to address moisture, and they still end up with moisture problem and flooring failure. So this first case study is a stadium renovation. The original construction in 1970s, the renovation was in 2016. The existing flooring was a loose laid rubber mat. The new flooring was adhered rubber mat with, before they applied the adhered rubber mat, they applied moisture mitigation membrane. Now, every time they apply moisture mitigation membrane, that means the slab will have to be prepped, shot blasted, and then you apply this liquid membrane. Typically, the cost of these membrane could be from $3 to $5 square feet. So they did that. They applied the floor, the rubber, the adhered rubber. Within the first year, after about 3 months, the floor failed and experienced blistering. The blistering looked something like this. I think Shayne had this picture on his slides, the earlier slides.
Should look familiar.
Yeah. And this is what happened at the floor. This second case study is another pre-K school renovation. Original construction, similar, 1970s, renovated in 2018. The existing flooring was a carpet tile, so the new flooring adhered to linoleum with welded seams, and moisture mitigation system was used too. So again, they invested the money in applying that moisture mitigation system. On top of that, this new adhered linoleum flooring. Within the first year, same thing, they experienced blistering.
So for the first two, they're following the industry.
Industry
recommendations, right?
Yeah,
Yeah.
industry standard, solution for moisture problem. And they still have this moisture issue. And here's a view of these blisters on that floor. I think we probably got a video for this, so we'll let you see this video of one of the blister. And that's what comes out of it. And this is a pre-K school. You got thousands of these blisters.
Any orders whatsoever.
No, the third case study is a new construction. This is where they added this alkali-silica admixture to mitigate the moisture. And those products, they claim that they lock the moisture inside the concrete, so you don't really have to worry about the moisture prior to installing your flooring. Well, they did that. They didn't put no vapor retarder under the slab because that admixture will lock that moisture inside your slab, so you don't need that. And then the concrete slab was covered with an epoxy floor coating system. And obviously the problem was within the first year, the epoxy flooring experienced blistering and peeling. Sorry for the typo here, says the rubber, but it's the epoxy flooring. And a couple, photos of what happened at this facility. You could see all the peeling of the epoxy floor covering, peeling with efflorescence on the inside. When you see a fluorescent, that's due to moisture traveling through the concrete. So it did not work. So for all these three case studies, general contractor followed industry standard as far as mitigating the moisture, but they still have problems. So what is missing? What's going on? What are we really not thinking about? And this is why we want to talk about the osmosis, the ASR, and the chemical contamination. So to talk about the osmosis, what it means is the movement of the water through the concrete from pure to less pure. So when you have a different in solution of the salt concentration within the concrete slab, the moisture gonna move from the pure side to the contaminated side, or the higher concentration, as you see on this illustration where that water is moving. And it's going to move until you equalize the concentration on both sides of this membrane, which is the concrete. So to look at that on the concrete slab, if you don't have a vapor retarder and you have a concrete slab with less concentration at the bottom, you can see those two red dots, and a lot of concentration at the top. And this could happen when you have a curing, when a curing compound applied to the top, or these silicate admixture applied to the top. The silicate will, end up being a water-soluble salt and leading to higher concentration at the top. That's why for a concrete slab to receive flooring, you're not allowed to use a curing compound, and you only should wet cure the slab for this reason, because that will lead to increasing of the solution, or the water soluble salts at the top. So what happened? You're going to have this osmosis as that moisture comes from the underside of your slab. You're going to, once you cap the floor, this movement of vapor moisture going to concentrate to, from the pure side of the concrete slab to the contaminated side with the higher concentration until it equalizes. And what happened once you cap it, it will end up with blistering of your flooring. And this is what we are seeing on a number of projects.
Because it causes pressure inside of the.
It does cause pressure. We haven't, I mean, some projects we've seen, once you punch through, the water starts shooting out of those blisters. It could get up to 300 PSI and even more at those blisters. So it's a lot of pressure there. Here's a view of how they look like from a microscopic, view of a blister. The second condition is alkali-silica reaction, ASR. So just to talk about ASR weathering, you have to have three principal conditions, and this include the reactive silica, and that's in the sand, the aggregate in the concrete, and the alkali. Well, concrete is, have high alkalis in it, and sufficient moisture. So if you have all these three conditions, you're going to end up with ASR. For the moisture, you pretty much need moisture of in excess of 80% to have ASR. We don't see this a lot on new construction. We still see it, but on number of projects, but not as old renovation projects where sand have reactive silica in it. And the problem with ASR, what happens, so the mechanism of ASR will form a gel that swells as it draws water from surrounding cements. And as that gel expand and it leads to cracking of the concrete, and it keeps drawing water. So you end up with cracking of the top of the concrete, and as it keeps drawing water, you end up with blistering as well, leading to flooring failure. Just to show you what happened on the concrete slab. So if the moisture is moving from high humidity to less humidity on the interior, once you cap your concrete, and this could be by the flooring or the moisture mitigation system, if you apply that at the top, it will cap your concrete. So what happened to the moisture? It's just going to condensate right below that membrane. And if there's active silica, sand, or in the concrete, what's going to happen is going to develop that gel that's going to expand and crack the concrete. And as that gel develops, there's just going to start drawing more water, leading to, same thing, blistering of the flooring system. Here's a view of an ASR gel expanded, leading to a failure of the bonding of the flooring system. This is another view, another example. Here's one more. Hydrocarbon contamination. This could be from old oil-based adhesive. That adhesive will, this hydrocarbon, the oil will soak down into the concrete, and if you don't remove it, you'll end up with issues on the bonding between the new flooring and the concrete slab. So with all these problem and that you have to look at before you install your flooring, as we talked in the iceberg, you can't really see all the contaminant, the ASR, or assess proper moisture without really by just visual or doing a calcium chloride. You have to take a concrete core and assess the concrete. Other than that, you're just gonna have to live with that risk of failure, and those could be really expensive. Those three projects we talked about, they did the right thing, but they still end up with a problem with the flooring that failed after 3-6 months within the first year, and they end up replacing that floor. And this is just really an expensive process. This is where that 2.4 billion number comes in, and then the 1.2 in just repairing those
because you really want to rely on the field testing, and you want to use that in conjunction with the core sampling. Because, for example, if you just do a calcium chloride test, or and you maybe do a pH test or something like that, and you use the two of them together, you say, oh, okay, I think I'm okay. You know, we're ready to install the floor covering. Well, that really doesn't give you an accurate picture of what's going on within your concrete slab. Those are only surface tests. And the moisture profile, the internal mechanisms inside the concrete slab don't become apparent until you start talking about doing RH testing and the core sampling and testing that you're talking about.
Exactly. So before I move into now, we talked about the problem, how to properly assess. I don't know if there's any question, please feel free to, or any comments before I move into the next section.
Nope, it's been good so far.
Okay, so now how to properly assess the flooring prior to apply the floor, to assess the concrete slab prior to apply the floor covering, so we don't end up with these problems that we discuss on those 3 case studies. You go and you just apply moisture mitigation, and you end up with failed system, and you've already wasted money on the mitigation, on the flooring, and now you have to start over again. Actually, I worked on a project where they did that process twice. They used sensitive adhesive, and it failed. They went back and said, let's do a mitigation system, and it failed. And the third time when we assessed that, said, well, you have some issues here. So you don't want to do that one or twice before, before you do the proper assessment. So the proper assessment is, typically a visual. The main thing is really core sampling. You have to take a core in order to figure out what's the contamination level, if there's ASR in the concrete, because once you cap it, you're going to end up with these osmosis and ASR expansion, and it'll be too late then. So taking a core, what we do to the core is we study the top 0 to 6 millimeter. We slice the core and we look at the soluble salt contamination at the top, the level. There's a normal level for the concrete, for sodium potassium. The reason we do sodium potassium chloride, sodium potassium is used in curing compound, where chloride could be used in admixture for or de-icing salt. Here's an example of projects where you could see the level of the sodium from 2610 at the top, 0 to 3 millimeter, to a normal level, and this is what kind of lead to that different concentration and the contamination that leads to osmosis. This is organic contaminant for the oil, hydrocarbon that could be from the old adhesive, and you can see the high level. So you want to look and see what kind of level of contamination you have, so you could address those prior to applying the moisture mitigation system or the floor covering.
Hey, Hyder, on the topic of testing for chlorides, we had a question come in. Do you conduct rapid chloride penetration testing on concrete cores?
Well, so the rapid chloride penetration, that's used mainly, it's considered for bridge decks and concrete, reinforced concrete. And the reason they do that, they want to make sure that chloride penetration is going to be less than anticipated for good quality concrete. Because if you have more penetration than expected, you could end up with a less service life of the concrete, because once that chloride reaches the rebar, it will expedite the corrosion process. It's going to lower the pH. It's going to expedite the corrosion process until it reaches the chloride threshold for concrete. for corrosion, that leads to corrosion of the reinforcement embedded in the concrete, typically, around 500 part per million. So in reinforced concrete, yes, we do it, but for flooring, we're really concerned about what's happening at that top 6 millimeter where your flooring going to be adhered to the top, and we want to make sure there is no difference in the concentration. We don't want to have 1,000 part per million at the top 6 millimeter and a 200 part per million at the bottom, and that will lead to that moisture movement to the top by osmosis. Same thing with sodium, potassium. Those could be from curing compound or in the concrete itself. So it does apply, but for reinforced concrete, not for the flooring. I hope this is kind of answers that. So I guess now we talked about the problem, how to properly assess. Now, how to avoid the moisture-related problem. So here, we developed some recommendation to consider for new construction. Always install, a moisture vapor retarder under the concrete, directly under the concrete. The current standard require a 10 mil with a permanence of 0.1 perm in accordance with ASTM E1745. And, we talked about the time, so it takes 6 months, 1 month per inch. So the time is important, allow sufficient time in your construction schedule to, maybe this could be done, by once you figure out the schedules for those different pours, different levels, when you're going to install the flooring. So this need to be worked out maybe during the planning of the project. So what would be the best time to install the floor covering, allowing a proper, an adequate time for drying of the concrete.
We talked about that one month per inch thickness.
Yeah, that's 1 month per 1 inch. And again, this could fluctuate. It could be less if you reduce the water cementitious ratio, or it could be more if you have higher water cementitious ratio.
Maybe the contractor added water.
Yeah, or adding water on site. So all of that affects this 1 month per an inch, but it's kind of like a rule of thumb. Ensure closure of the building as soon as possible. So maybe start with the roof and close the building, and think about that before you install your flooring. Always wet cure the concrete slab. Don't use topical curing silicate. And this is on the ACI guideline 302.2R. The other thing is, nowadays we've been seeing those silicate admixture. They sometimes they add them to the mix at the concrete batch plant prior to sending to a project, and sometimes they also add them on site as a topical. So don't do that. It's just going to lead to more soluble salt at the top, leading to osmosis issue. And we'll go over the use of these admixture in the concrete as well. As far as ASR with new concrete, we're seeing less and less now, because most of these plants, they have certification for their aggregate to meet all the industry standards when it comes to the level of ASR. But there are still a number of projects where we still see ASR until now. So maybe each state has their DOT where they have specific requirement and protocols to mitigate ASR. Maybe reference those on your spec for the concrete.
Hey, Hyder, real quick before you move on, as far as the vapor retarder goes and placing it under the concrete slab, we worked on a project fairly recently where we did some RH probes, and our results were somewhere in like the low to mid 90s. So we're 92 to 95, and we did a core, and So there's no vapor retarder under here. Well, what's going on? All of our research, all of our, technical references that we're looking at tells us, we should see near 100%. I mean, we're talking 98, 99. And we said, well, what gives? What's going on? So we actually did hand augering, and we found a vapor retarder 7, 8, 9 inches below the concrete slab.
That's the old standard. And
That's the old
actually,
standard.
I have 2 slides to talk about that. So the old standard, and thank you, Shayne, for bringing this up. So you're talking about the vapor retarder placement. Back in the days, the guideline, the industry, it was best practice to install the vapor retarder under a sand layer, a cushion layer, blotter layer below the concrete slab for 2 reasons. Shayne, you want to comment on the 2 reasons why they did that?
Yeah, I think
so they have the vapor retarder at not below the concrete slab, but at whatever 6 inches of that sand layer.
Right. So I think a kind of a common sense answer might be like, hey, as the laborers are walking over the reinforcement, there's chairs underneath the reinforcement to provide concrete cover at the bottom of the slab. So you might get a puncture, you might get a tear, you might have some tape that when it's placed down at seams, there might have been some dust or something collected on the underside, and it might not be sticking or adhering properly. So you could get some sort of breach in the vapor retarder. And a little bit more of a kind of a technical reason would have been to prevent curling, right?
Yep.
So you get moisture source coming from below the concrete slab, so there's not a difference in drying between the top and the bottom.
Yeah, so it's really drying to the top and the bottom, the sand layer, and it reduces curling, which is, it does help. But the problem is, if you get a breach in that vapor retarder, what happened to that water as it gets through from the layer below that? So water, moisture gets in, it's going to freely travel in that sand layer. It's just going to be a reservoir underneath that concrete slab, leading to RH of close to 100% right below the slab, and we end up with the same problem. So that's why this is no longer recommended. Now we have to have that vapor retarder right underneath that slab. It's just better. We still see few spec out there. They still use that old method, but we recommend not to have that vapor retarder below that blotter layer. It should be directly under the slab.
Yeah, it might prove successful as far as not ripping it or
curling.
Yeah.
But you have moisture problems. So it could be used on a floor where you don't have a flooring specified, or could be a polished finish that could be used. But
right.
If you have a floor covering, not non-breathable, you should consider that vapor retarder right underneath the slab.
And we all know that when a slab is constructed prior to when you're placing the sand down there, or whatever sort of base material you have, we all know that it's not going to be constructed with no moisture content in the sand. There's going to be moisture in the sand when it's constructed.
Yep.
So.
And again, the reason, if you get a breach now in this vapor retarder when it's directly under the slab, the only area it's going to be affected is right directly where that breach is. It's not going to extend to the rest of the area below the slab.
Hey, Hayder and Shayne.
Yes.
This is Deb. I don't know if you saw, we have another question come in about
Yes.
whether or not a thin layer of ultra high performance concrete overlay would help solve the moisture issue. There's more detail to the question in the chat bar. Shayne, maybe you want to take a look.
Yeah, and it says the UHPC is a modern concrete where it has a negligible absorption rate and liquid transmission. It also has superior resistance to ASR. So yeah, Kristen, just as you brought that up, Deb, Kristen brought that in and brought it to our attention.
Yeah, so there are, other solution out there. There is this one solution, Autodex, I'm not sure the name, but it's a concrete with water cementitious ratio that are 0.3 or less. The problem with that is the workability. We talked to a number of general contractor. The first thing, it's expensive, concrete workability, and if you pump the concrete. Now, the question is the ultra high moisture covering or overlayment on top. A lot of those mitigate, I'm trying, what's the question, Shayne? You have the
It was the overlay, I think.
overlayment.
Yeah.
They manufacturer, they have these products, you could, mitigate ASR. And the reason for that, we're going to go over this. Actually, we have a sample of that. The reason they mitigate ASR, because we talked about three principal conditions for ASR. You need your moisture, you need your ASR, active silica, in this, in the aggregate sands in the mix, and you need your high alkali. High alkali and moisture available there. Alkali, the concrete, it's there, and then the moisture is there. So if you put a mix with no active silica, aggregate, you just gonna remove that ASR.
So
You're removing one component and you end up with a layer that are free of ASR, no ASR problem. So it does solve the ASR.
Yeah, because I was gonna say that the UHPC, so it's talking about having a negligible absorption rate and as well as liquid transmission. So you're talking about removing one of those components of the ASR.
Yep.
As far as this goes. And
So
our recommendations do incorporate something similar.
So it does work, but the problem is if you cap your, the top of that with a non-breathable flooring system, that moisture drive is still coming. So you have to still consider the vapor moisture drive when using these products. Yes, they work to mitigate ASR, but you still have issues with excessive vapor drive. And if you put non-breathable flooring, you have to still be concerned about the adhesive. You could use maybe adhesive that tolerate higher moisture, but you have to worry, maybe about mold underneath your flooring. So there is no one, one solution that fix all the problem here. You have to think all of these different aspects. But with regard to ASR, it does mitigate ASR. So we going back to this admixture. We see a lot of projects nowadays relying on those admixture, and we get asked, do you support the use of these admixture products, those silicate product or not? Now, I just want to bring, this product, they've been out in the market for the last 30 years. They're not new product. They've been out there for the last 30 years. However, their effectiveness in mitigating the vapor moisture, it's not really established. It's not clearly established. There is no standard out there that regulate the use of these products. Even the flooring manufacturers, when we, go do testing for moisture, we go by the requirement that are set in the specification of the flooring manufacturer. Those could be RH for sure, obviously, or calcium chloride, but nothing mentioned about because when you use these products, they tell you we lock the moisture inside, therefore you don't need to do moisture testing. And when you reference the specification from the manufacturer, it does require the moisture testing. So there is no standard. The only standard out there is for two-component epoxy mitigation system. There is no standard for the use of the admixture. So that's the first thing. The other thing is what we recommend is when you use these moisture mitigation product, you need to make sure they stop the vapor moisture drive through your concrete. Because the problem is we see a lot of those manufacturers providing these admixture product, they put in their data sheet that they stop the hydraulic movement or the water movement through the concrete. We're not talking about water movement through the concrete. Concrete is waterproof. We're talking about vapor moisture drive. So the movement of moisture vapor and gas through the concrete, not the water, liquid water. And to do that, ASTM E96 standard test method for water vapor transmission of material, that would be the test to make sure that you meet that standard for these admixture. And just to give you an example, we looked at a project where they applied this admixture and it failed, and we got involved, and some of the I guess document that we looked at was the warranty from the admixer company. And in their requirement, they you could see this number 7 say, they require the, testing concrete per ASTM D5084 with minimum requirement of 6 times 10 minus 8 centimeter per second permeability. And again, this ASTM D5084, it's for water movement through the concrete. It's not for vapor movement. And this is the issue. Actually, in fact, if like permeability of good concrete is approximately 1 times 10 minus 10 centimeter per second. So you could get less permeable concrete by, just by having a good quality concrete. And that's less permeable than the treated concrete with admixture. And so it doesn't make sense. And I left this number 8 requirement. They require moisture testing, and it's really, they contradict what they talk about. They say we lock the moisture. You don't need to do moisture testing, and in their warranty, they require you to do moisture testing and then conduct it by the manufacturer prior to installing flooring. So it's just contradict what the product is tending to do to your concrete. Looks like we're running pretty close to our time here. So this is with admixture. The renovation, this is where the issue is. So for coring is a must when we do renovation project. The reason for that, we want to study the presence of ASR, soluble alkali with a chemical, and any surface integrity issue. Hydrocarbon may be present, the organic contamination. We do moisture testing, and then you select your flooring system by using a test area mock-up. That would be the best thing to do, prior to doing a full scale. So now, if you do your testing and you find issues, ASR, chemical contamination, what are your options? You could cover and do mitigation and you end up with failing floor, or maybe, you do other things like polished concrete finish, and it's breathable, so you don't have to cap the floor, the concrete, and it's breathable system, you don't have this issue. If you really want to have that flooring, maybe then you need to do the concrete shaving, blasting, and underlayment. This is where you could do this ultra hydraulic cement layer overlayment at the top, or maybe you could consider alternative flooring. It's breathable, semi-breathable. Some of those are really thin and therefore they're not really durable. Other option might be a non-adhered flooring. Breathable, polished concrete, it could really be, a good system, obviously, because we're talking about something that's breathable. You're not gonna cap that, block that moisture inside the concrete, and it looks good too. So that could be done, and basically you're grinding, you're densifying your concrete because it's going to be exposed to the abrasion effect by the traffic. So you want to grind, densify, and then polish it, grind it more, and then apply a sealer. You could have different finishes, different exposure, aggregate exposure. and different appearance level too with polished concrete. The concrete shaving and underlayment, this is the option where we talked about if you have ASR. So the problem is you want to replace that top layer at the top of the concrete with a new layer that does not have active silica sand or aggregate in it, this new hydraulic cement layer. And once you cap it, now what happened is you don't have that elements there anymore. Therefore, your ASR is not going to develop because you need all these three for ASR to occur, and you eliminating those reactive silica from there at the top. Here's an example of a project we've done. It's one of those case study. We did it last year. We did the shaving and the overlayment, and it's been almost a year, no issues. So basically shaving the concrete, prepping the floor, applying your cementitious underlayment, and then you still put the moisture mitigation system because they wanted to go with non-breathable flooring system. So we had to put that mitigation system at the top. Now, even if the moisture is going to condensate, it's going to condensate within that top new layer that has no active silica, reactive silica, and no ASR. And it worked just fine for almost a year now. This is when, you know, they put self-leveling prior to the flooring and the job is complete. The problem, this is kind of expensive process. So that's one of the, I guess, the main issue with this kind of treatment. For CEUs, we're done with our presentation. So if you have any question, comments regarding credit hours, you could email Kristen. This is her email address listed here with her contact information. Kristen will have this available to you as well. And that's it. If you have any questions or comments.
Thanks, guys.
Thank you.
If anybody has questions or comments, feel free to unmute or type into the chat here. We'll wait just a couple of more minutes before we wrap up.
Hi, guys. I
Hi.
just wanted to say thank you for inviting me.
Hey, Jose.
Hey, I wasn't able to listen 100% of the whole time, so I hope I'll be able to get the presentation because we're still working from home. And as you can hear, I have my 3.5 years old right here. So, but thank you so much, seriously, for what.
Yeah, sure. We're glad you could attend and listen in on what you could there.
Okay, I think I don't see any other questions, so I think we're good. We will make a recording. We'll send a link so that everyone has the recording. And if you have any questions, again, you can follow up with me or Shayne or Hayder. And I want to thank everyone again for joining, and stay tuned. We'll be announcing the rest of the topics in the webinar series coming up in the next couple of weeks. I hope everyone has a great Tuesday afternoon and a wonderful rest of the week.